All right, non-rectangles. Let's start with the easiest non-rectangle. So, exactly. Here's a triangle. I'm going to call this one T1 and this one over here T2. This is the line, y is x. Cool. All right, so my example is I just want to integrate over T1 x squared dx. dx? I just flipped this up. The area, right? Okay, so you get to pick, right? So right now I'm talking about T1, so I'm going to kind of drop maybe I won't drop T2. So here's T1, right? Okay. You want to write this in terms of x and y, right? So which one do you want to do first? X. You do the double integral of x squared dx dy. Okay.
That'd be horizontal strips, right?
Yeah, so first things first, right? We're setting y as constant, so we're going to do horizontal stripes. You guys all see that? So if I set y as constant, I get this little horizontal bit. Okay. Now, this is the tricky part. Okay. Oh, whoops, I need limit. That's what I'm going for. So you want to do x to 1?
It'd be y. It'd be for the x's.
Wouldn't x be 0, 1, and y would be x to 1?
Okay. So if I do 0 to 1, right? This thing will kill the x's, right? You guys all see that? Yeah. And then I'll integrate and I'll get x's back. What's this going to give me? You guys see why I'm going to get x's back? Should we try this?
Sure.
Okay, so I'm hoping it's this. So let me step to the side here and calculate the integral from x to 1, the integral from 0 to 1 of x squared dx dy. Okay? So, what do I get?
No, x to the third over 3.
Integral from x to 1 of x to the third over 3, evaluated
0, 1,
0 to 1, dy, right? Okay, so then do the evaluation bit. So you're going to get the integral from x to 1 of 1/3, and then you're integrating dy, right?
okay.
You guys see the problem? So I'm going to get some y's, right? And then I'm going to sub x in for it, and I'm going to get, in the end,
Yeah, you don't get a number.
well, maybe not f, right? But some frickin' function of x. Well, I guess I didn't have an f, so f would have been fine. But I get some function of x, right? How do I know I've screwed this up?
The outside integral has x's in it.
The outside integral shouldn't have variables in it, because
You put them back in, and you want to get them out.
I'll put them back in, then I won't be able to get them out, and categorically, right, at the end I'm supposed to get a yeah, you better get a number, right? It's supposed to be a volume.
So then
So when you do
0 to 1 and then 0 to 1.
Okay.
you just flip them. You do 0, 1 on the outside.
0, 1, 0, 1 would be just that square.
Integrating a number would.
Okay, so that didn't work. So what you want to ask yourself is, where do the x's go, right? So I'm integrating dx, right? That's holding y constant. So I'm going to draw this little rectangle in here. And then, where do the x's range from? Like, in this rectangle, where do the x's start?
0.
In this rectangle, right?
At 1 minus
They
x.
Oh,
start
yeah,
here.
They start at y.
They start at y, right? You guys see that?
Oh.
So it's got to be in terms of the other variable, right? So they start at y and go to
1.
1. So we're integrating from y to 1. And then where do the y's go?
From
From 0 to 1.
so the outside has to be numbers only.
Yeah, so outside has to be numbers only. The inside integral can include, in its limits, the
Other variable.
Other.
other variable, right? The variable for the outside limit. I really, really, really recommend that you draw the picture and make these little slices. You guys see that? Okay, so can we execute this?
X cubed over 3.
So I get the integral from 0 to 1 of x cubed over 3. And then we need to evaluate from y to 1 and then integrate dy, right?
Is it okay to not use parentheses for that? Is that like, that's cool? I mean, can you not use them
Yeah.
and have, okay.
As long as you remember to put the evaluates in there,
Mm.
I'm okay with it.
And if you're doing addition, you would need the parentheses.
Yeah, if you're adding or subtracting or otherwise
Mhm.
operating, I'd throw them in. When in doubt, throw them in,
Mhm.
but you're okay without.
1/3 minus y cubed over 3.
So I get the integral from 0 to 1 of 1/3 minus y cubed over 3. Yeah?
1/3 y.
And then I'm integrating dy, right? Okay, so I'll get
1/3 y minus y to the 4th.
I think 12 was right. Yeah. Okay, so I got 1/3 y minus y to the 4th over 12.
0 to 1.
Yeah.
Oh yeah, remember to evaluate it, right? You're still not supposed to get a function. So we're evaluating from
0 to 1.
0 to 1.
Good joke, yeah.
1/3 minus 1/12.
So I got a third minus a 12th,
Which is a quarter.
which is good. Do not do more arithmetic than you have to. Human beings are bad at arithmetic.
Yay.
It's okay. Should be good at calculus though. Alright, so I got a third minus a 12th, which is apparently a quarter. Okay, great. Does that make sense?
If you were to draw it, it looks kind of right.
Okay, so,
And so that's the area of
That's what we got.
T1.
okay, so that's the volume of the surface x squared. So let's try to draw this. I think we can make a decent picture here. So let me see. So I've got a z-axis, right? And x squared looks like this, yeah? So here's x. Y goes back that way, right? And what have I said about y in my function f? Not here, but in my function. The function I was integrating was x squared, right?
Y is not defined.
So y is whatever, right?
Anything, yeah.
Which means this is a kind of U-shaped cylinder run backward and forward, right? Okay, and now my axis is going to get in the way. Alright, so I've got my U-shapes, right, running forward and backward. And now I want to know about over this triangle. You guys see that? So here's my triangle. So that's going to be high up here, right? High up here. And then drop down into this corner.
So quarter pipe.
Yeah.
So if it was the whole square, right, it would be a quarter pipe.
So it's
So what I've taken is
Oh,
I took
yeah,
a
yeah,
quarter
yeah.
pipe and cut it in half from the low corner in the front to the high corner in the back.
Okay.
Oh, actually, we could totally draw that on one of these.
Yeah.
You guys see the quarter pipe?
Yeah.
Should we take one of the things and draw it?
Well, you
Well,
already
one's
broke one in
broken.
half.
Oh, I broke one in half.
What a wonderful happenstance.
You meant to do it, right?
Yeah, totally.
We're gonna break that in half.
Oh yeah, we could.
It's a nice little
I am not going to, but okay. So here's our little quarter pipe. So let's align it with our axes. So I've got x this way, right? Y this way. And I'm talking about over this triangle. So that triangle on here is this, right? So I'm talking about the volume of this piece of cement outlined in blue. You guys all see that? Cool. So from this, with this little visual, can you guys tell me whether this 1/4, is that going to be the same as if I did over T2?
No.
You guys see that? So T2 on this,
T2, we're going to have two low values.
right, would be this. So here, here, and this side, right?
Yeah, that'd be
Is
a
it
Yeah.
kind of like the max and min?
Yeah.
Is that the same?
Shouldn't
Oh no,
so.
no.
Probably not. So the reason it's probably not is that on the,
Oh, it's the.
The two highs on the first.
yeah,
one,
it's
two lows
more
on
on the low side, right? There's more area on this low edge. On the blue one, right, T1, I've got more area on the blue side. You guys see that? Cool. So I will give you guys your choice. There are several things I'd like to do here. You want to switch the order of integration on this one? Let's try it. So I should be able to do this same question, right? By doing, instead of dx dy, doing dy dx. You guys see that? Right, I said it didn't matter. So we should be able to switch them. So this should be the integral of something and something, of x squared dy dx.
And so now we're figuring out
So
the
Wait,
T2.
hang on. Let me do this. This will make it easier to watch on the